And we're live. Welcome to another edition of RockSim Live. I am Tim Van Milligan, and this is where we talk about RockSim, RockSim Pro, and the Launch Visualizer. It's been a great week. How was yours? I've got a chat going, and we've got Carlos in Marietta, Georgia, and he says that he is damp after 8 inches of rain from the hurricane that just went through. But otherwise, they're unscathed, so that's really good to hear. We're very concerned about those people along the panhandle of Florida, Pensacola, Tallahassee. My wife went to Florida State University down in Tallahassee, so we are familiar with the area. So, our thoughts and prayers are with you guys there. So hopefully it will dry out, and hopefully the damage is minimal. It was a big hurricane, so it probably wasn't, but I'm crossing my fingers. So my thoughts and prayers are with you guys, and hope everybody's safe, and hopefully we can dry out and get back to rockets there in Florida. We have Johan de Sloper from the Netherlands. So he is safe from the hurricane. He says he still have a rocket on the table to be glued. I just hate epoxy. Just 30 seconds ago, I was working on this one. This is the upper stage of the Nike Hercules, and there's only one more piece I have to put on here, plus the paint and the decals, and then this part is done. I am so happy to be almost done. I've been in the photo booth for the last few weeks, just building this rocket and making the videos for it. The release, we're still not sure on the release date. But we still have the instructions to do, the printed instructions. The video instructions are moving along, as I said. But there's going to be printed instructions so that for those people that don't want to watch my ugly face on a video, you could just follow along in the printed instructions. There's only over 200 steps. We have to do illustrations for all of those, so it's going to take a little bit of time. I've got some outside artists that are working on it as well, so that we can try to get them as fast as possible. We wanted to get this done by the end of the year, and we're still making that push. It's going to be a great kit. We've been having just a blast flying it. It can be flown as a low power model rocket or a high power, depending on which motors you fly in it. The booster stage has 4 motors in the booster, 429 millimeters in the booster. Can you see that? And then the upper stage has a single 29 millimeter. So it's got a lot of motor combinations that you can use. You can use Estes motors in it, Estes 29s. If you want to go, the least expensive flight. More impressive are the Airtech and Cesaroni motors, of course. It's just been a blast. Learning a lot about it too. When you're putting it together, you say, I wonder what this piece is used for on the real rocket. And then in the instructions, you get to find out. So you get to learn a little history too. Johan says, ooh, even better. Nike Herc. I know a guy that was in the squadron in Germany with the Nike Hercules. Yeah, there's a bunch of people around. That was in the 1960s and early 70s, and then it was used in other countries as well, South Korea, Turkey, a bunch of countries. I think maybe Japan had it. So there's a lot of them around. There's a lot of people that worked on it. If you can find one of those people, listen to them. Let them talk your ear off about all the stories that they have about that thing. It was, originally it was nuclear tipped, but then they turned it into a conventional warhead. when they discovered that, putting a nuclear bomb over your own territory is not quite the thing you might want to do. Terry Wheelock is here, and he says, does it explode? One of our flights, we had a Kato in the booster stage. So it had 4 motors, and one of them Kato'd, and it blew out the side. But it still worked fine. The other 3 motors were still able to lift it successfully. It staged nice. But yeah, that's the only explodey thing that I want to see. There's not a lot of room inside for anything other than the parachute. I mean, I guess I'll talk about this some more. So right here is an eBay. Let me pull the little rivet out. If I can get it out. I'm trying to do it upside down. There we go. So inside of here is an eBay that controls the ignition going out. Come on, YouTube. Tell me if you're live. I'm still streaming. I'm still here. Trying to get the feed going. Tim is back. Oh, good. I'm back. So what did you guys miss? I was talking about the upper stage, and these fins up here are called destabilizing fins on the real rocket. So what does that tell you? Is that they wanted this rocket to be unstable. We had to put a lot of nose weight in it. And you can't tell by looking at it, but these back elevons back here are actually canted a few degrees. And then the purpose of that is to give the rocket some spin so that it will fly straight. Okay. Okay, anyway. We're here to talk about RockSim. So here is the Apogee website. And what I'm looking at is the RockSim video tutorials. And yeah, so to get here, if you want to learn more about the videos, go to How To and Guides, come down here to Software, and then come down here to Video Tutorials. Right now we're doing RockSim Live Training. If you'd like a free trial of RockSim, go over here. If you want to know what RockSim does, go here, find out the extra features, and frequently asked questions and the version history are all located right there. I have nothing to talk about other than what questions that you have about RockSim. So go ahead and put them in the database or in the chat. I appreciate you guys sticking through this. On my computer, I'm just getting a spinny ball. But according to the chat, you're still here. What? I'm going to type in the chat. What are your RockSim questions today? Let's see if anybody has one. What was I doing this week? Can RockSim design one of those Vietnam hoop rockets? No. I think he's talking about they make a disc-shaped rocket, and they put motors around the outside, and they spin it, and it spins upwards. No, RockSim cannot. It has to figure out where it has to be long and skinny. We have a question from Stark03. He says, does RockSim figure out where the rail buttons go? All right, well, that's a good question. So let's, I'll tell you where I put mine. So let's open up a design here. Designs, let's go to Apogee, open that folder, and go down to the Zephyr. Okay, so here's the Zephyr. And if you look at it in 3D, it looks like this. And you can see where I've got my launch lugs, but they're actually, in real life, they're buttons, but we don't have a button part in the database, so we use launch lugs to simulate them. So to place rail buttons or launch lugs, what I do is you want to find the center of gravity of the rocket. So what's so important about the center of gravity? That's the balance point of your rocket. So if you hold it on your finger and the rocket's laying there, that's where it's going to balance. That's where the center of gravity is. But the interesting thing about the center of gravity is that's also the point where the rocket's going to rotate about. So if you took the rocket and you just spun it in the air, it would rotate about that center of gravity. So let me put a rocket motor in here. And I don't know which one we go in, H120, H100. It doesn't matter with the delay. Click OK. So when we put the rocket motor in, you see the center of gravity moved backwards. So ideally, since the rocket is going to rotate around the center of gravity, that's where the torque forces are the lowest on the rocket. So, torque is, it's kind of like the pivot point. And the further away from that point, the greater the forces are going to be. So if you put a launch lug like as far away from the center of gravity as possible, that's the point on the rocket that it's going to be the easiest to pop off. So we don't want it to be easy to pop off because we need it nice and stable while it's on the rod. So if you only had one launch lug, what you would do is put it right, span the center of gravity with the biggest motor in it that you're planning on using. And that's the strongest point for just one launch lug. If you have two launch lugs or rail buttons, ideally you want to put one behind the center of gravity somewhere and one in front. And actually, the further apart they are, this is the case where you want to put them up far apart because it gives you more stability along the launch rod. On the Zephyr, you can see one of them is right here and one of them is right here. So the one in the back, we put it as far back as possible. And the other nice thing about putting it as far back as possible is it makes it easier to load onto the launch pad because you can, if the rocket's up in the air, you can see, the tip of the rod and the bottom of the launch lug are the closest together they're going to be. And so putting it on the pad is easier when you have one of them that's as far back as possible. So we put one right back there. And then ideally, we would have put this one up here. But we didn't for a reason. And the reason we didn't on this particular rocket is this, this tube coupler right here. So this is a rail button. And if you look at our rail buttons, let me go to the Apogee website. If I can spell right. It's giving me an error. What's going on? Rail buttons, there we go. Okay, so our rail buttons are three pieces. You got the button itself, a screw, and then this right here is called a weld nut. And the weld nut goes on the inside of the rocket. So if here's a tube, and we cut it in half, and we're looking at the inside. So on the inside, we see the weld nut, and on the outside, we see the button, and then the screw goes through the button into the weld nut to hold it in place. Well, on this rocket, because of that tube coupler, we couldn't put a hole in the rocket for that weld nut. So this whole area right here was off limits. We couldn't use it. So we could either put it up front or put it behind. Now, ideally, I would love to have put it in front. That would have been a better location. But there's a reason we didn't do that, and it's because this tube right here, we wanted to keep the price of the kit as low as possible. And by putting the rail button here, we would have had to put a hole in this tube. And otherwise, there's no holes in this tube, so it would have cost us extra money to chuck this up and use our laser to cut a hole in it. Whereas on the bottom tube right here, we're already chucking that one up because we're cutting slots for the fins and we're cutting a hole for that launch lug or rail button. So we said, well, we might as well put that rail button into this tube so we don't have to, add more expense to the rocket and make the customer pay a lot more money for it. So that's why we put that rail button there. So it was kind of thinking ahead on where parts were located. So that's a really good question, Sturk. Where to put that button. And it's, ideally we would have put it up here, but because of practical reasons, we moved it back here. And the rocket still flies fine with it that way. It's just, in a perfect world, we would have put it on the other tube. Apparently, I get disconnected and then I reconnected. Carlos says, group hint, I keep a Pages doc open at all times and jot down concise RockSim Live questions. And then he sends them to me by email, which I appreciate. That's thinking ahead. I like that. Terry Wheelock says, can we simulate more than 3 stages in RockSim so I can launch a rocket to the moon? The answer is maybe. Okay, let's go design a 3-stage rocket. Let's find a 3-stage rocket. I think Estes has one in their database. So let's go to the designs. Estes, open, and then I think the far side, if you're in your database, Mosquito, Lodestar, Double Ringer, Alpha, Big Bird, not there. Might be in miscellaneous rockets. Is there miscellaneous? US rockets. Out of production kits. Estes, Nike, Cajun. I'm not seeing it. Okay, we'll open a Nike Cajun. Do I want to save that one? No. Okay, so here's a 2-stage rocket. Let's put another booster on this rocket. So I opened up a rocket. Is this actually a 2-stage rocket? That's a good question. Yes, it is. So we have the sustainer, which is this part right here. Hopefully you can see my mouse. It's kind of small. And then we have the booster down here. Oh, Sturk says Comanche 3. Yeah, we could have done that, but this will work just fine. So we're going to design a 3-stage rocket. In fact, what I'm going to do is I'm going to take this booster and I wonder if I can copy it. Nope, I can't copy it. Let's copy the body tube. Nope, not that tube. I want this tube right here. Okay, so that body tube, I'm going to copy it. And then what I'm going to do, when you copy the tube, it copies everything that's connected to it. So if I collapsed it, and so everything below the little caret has been copied with it. And then I'm going to go to the Rocket Design Attributes tab, and I'm going to turn it into a 3-stage rocket. Okay, so now it's a 3-stage rocket. So if I go back to Rocket Design Components, you see I have Booster 2, Booster 1, and the sustainer. So it's now 3 stages. So I'm going to go to Booster 1, which is the 3rd stage, the bottom stage, which is not there right now. And then I'm going to paste that tube. So it pasted the tube here, but you're not seeing it because right now I'm only showing 2 stages. So if I go here and show 3 stages, now I see my tube. And I got these long lines here are kind of a remnant of something. Let's open up the fins. And let's just change the location. Yeah. Okay, so I'm moving those tubes back there. All right, so now we have a 3-stage rocket. And if we fly it, let's fly it first. So choose engines. So these are all 13 millimeter. So I'm going to choose A10-0, and I'm going to load that one into all the tubes. So it loaded the motor into that tube, and that tube. But now this upper stage tube, I want to change the motor. So on this one, I'm going to double click to open up the database. I'm going to change it to an A3-6 and click OK. And let's launch this thing just to get some data. So the sustainer is going to deploy a maximum engine ejection. Starting state is straight up on a 48-inch long launch rod. Launch conditions 700 feet above sea level, 8-mile-an-hour wind. Let's launch it. Okay, so here's our 3-stage rocket, and when we launch it, it goes up. Okay, so there's the stages have fallen off her. So here's one of them that landed. Here's the second one that's coming down, and then here's our 3rd stage. And you can see the problem with a 3-stage rocket, and I think we launched this straight up, is they tend to weathercock into the wind. And ideally, to assume that this is a good flight, we want the apogee point, which is the highest point in the flight, which is probably this point. We want it inside of this V, and we call this the weathercocking cone because it's a cone. And we want that apogee point inside because that what it tells us is the rocket's going more straight than sideways. When it goes outside the cone, we're flying in a direction that we don't want to go. So that's the problem with 3 stages, and that's why the National Association of Rocketry and EEE have limited in their safety code the number of stages to 3. Because we don't want to weathercock and go sideways. The more stages you have, the further it's going to go. All right. So how do you add more stages to the rocket? Well, this is kind of an advanced trick. Let's see if it works. So what we're going to do is we're going to add a pod onto this booster stage, or maybe the 2nd stage. Which one do we want to add it to? Let's try the booster stage. And if that doesn't work, we'll go to the upper stage. So I'm going to go to the Rocket Design Components. So we have 2 boosters. I'm going to do this one here. Can I change the name? No. I'm going to add it here. I'm going to add a pod. No, I'm going to add it to the bottom stage. I think it'll be easier for me to do this way. So I'm going to add a pod. So I'm going to come over. Nope, I got to select which component. I'm going to add it to this component here. I'm going to add a pod. So a pod is anything strapped to the outside of the rocket other than fins and launch lugs. So here is Let me make this bigger. So right now, the location of this pod, so typically pods are used for strap-on boosters on the outside of the rocket. So what we're going to do, what I'm going to try to do is going to try to take that pod and move it back here and then attach the motor back here. So this pod can be ejected. And the location, I'm going to change it from the base of the owning part. I'm going to make it 0 inches, hit the tab key, and it moved it back here. So this is where it's going to be attached. Now I'm going to say OK. So now we have a pod, and if I can, remember I copied the components of that pod. So let's see if I can paste it onto the pod here. So I'm going to do paste. Yes, and sure enough, it did. It pasted the pod. Let me go to 3D so you can kind of see it better. So we have a pod on the outside of the rocket. Now I want to move that pod to the back. So let's see if we can start moving things around. So first of all, I'm going to move that fin set. I'm going to change the color so we can see it. Let's make it red. So those are my fins right there. And I'm going to move it to the general tab, to the location at 0. So I moved it to the back. And say OK. And now let's take this tube here and edit the tube. Let's see if we can edit this tube. I've never tried this before. Terry gave me an idea, making me think. So let's change that color of the tube, make it easier to see. So let's make it a dark color. So there's the tube. And what we want to do, okay, so we have, I can't move it from here. What I was looking for was the radial position tab. And I can't move it. So let's go to the pod itself. Now the pod itself does have a radial position tab. And let's say automatically calculate the radial distance. I'm going to turn that off and automatically calculate the radial angle. Now the radial distance right now is set to 1.32. So from this center line, this location is 1.32 inches. So I'm going to move it back to 0 and see what happens. And sure enough, it moved it back. We don't need to do anything with the radial angle. Let's go to the General tab, and now let's change the location. Oh, look at this. We're sliding it back. Let me zoom in here. Okay, so what we're looking at is I'm trying to figure out where the end of the tube is. So the end of the tube is this line. Okay, so it allowed me to move it all the way back and say, okay. Okay, so technically at this point, we have a 4-stage rocket that's built into 3 stages. So let's see if we can launch it. Okay, so now, let me save this in case I lose it. File, save as. Let's put it on the desktop. Let's call it the Estes Nike Cajun. No, we gotta have 3 Cajuns. No, it's 3 Nikes. Estes Nike Cajun. Nike. We gotta get the name right. There's 3 Nikes. Nike, Cajun. Because this stage right here is a Nike, that's a Nike, that's a Nike. On my Nike Hercules that I showed you earlier, they took 4 of them and they strapped them together. in a cluster. So this is 4 of them linear, like a train. All right, so let's see if we can set up a launch simulation. So we're going to go to the simulation properties, and you can see there's the 4 stages. And it's showing my 4th motor. I got a remnant here of something. But there's actually, this is the upper stage, the sustainer, which is the Cajun body. This is the stuffer tube. And this name here is what was the name of the engine mount. So we have 3 stuffer tubes because I copied them all. So this 4th one here is actually a pod. And so I'm going to choose an engine. I'm going to make it an A10 0. Okay. What did I do? Did I not choose the right one? A10 0. There we go. Okay, so it added a 4th motor. Now, how do we get that one to ignite before this one? So we can try putting an ignition delay on this motor. So this is the motor of the... I'm getting confused. That's the motor that's in this tube right here. And so what we need to know is the burn time of an A10. So I'm going to go choose an engine. And what I'm looking for, here's the A10, and has a burn time of 0.85 seconds. So I want to make the ignition delay 0.85 seconds. So what should happen when I'm crossing my fingers is that this one lights, then that one lights, and then these upper stage light. Don't know if it's going to work. And here's the thing. It won't show it in the 2D launch visualizer because that only is set up for 3 stages. The only way we're going to know if it actually worked is by looking at the altitude or the... Well, I think we can look at the graphs. Okay, so we got everything loaded, and let's launch and see what happens. And no, this is not good. 13 millimeter, 13 millimeter, 13 millimeter. Our altitude at deployment was 400 feet approximately. Our maximum altitude was only 425 feet. So it did not go very high. Let's see if the flight profile, I'm thinking that what happened is it went like this. Let's see. Oh, look at this. The upper stage ejected too early. Did you see that? If you kind of watch it, let me back it up. So watch it, because it was going really fast when that upper stage ejected. It ejected kind of like at burnout. So it did go sideways, which I expected. Why did it A10, A10, A10? Oh, it should have been an this one should have been an A3. Let's try that again. A3-6. Click OK. And then flight profile. So I expect it to be in the air longer this time. Okay, that was better. It's not ejecting so early this time. It's still going really far horizontal, and now it's coming down, and okay. But we can't tell from the flight profile if all 4 stages ignited. So let's go to the graphs. And what I want to plot here on the graph, along the x-axis, I'm going to use time, and then I want to go thrust. And what I want to see is 4 separate spikes of thrust. And then we'll do altitude. It really doesn't matter. We're just confirming. that all 4 motors ignited and in the right order. So let's plot the graph. And let's make this bigger so we can see it. And I am seeing 4 spikes. So there's 1, 2, 3, 4. I did it! I did a 4-stage rocket. Do you know what this means? This is a lot. This is big. This is really big. This is another feature, because if I can do 4 stages, what prevents me from doing 5 or 6? Terry says, to combat weathercocking on multi-stage, you gotta minimize the fin size so that the rocket goes straight up. Okay, so while I've been talking here, let me save this again. Let me check these comments here. So we got Robert Monday here. He says, "Hi, Tim. I am trying to change the CG in RockSim by adding nose weight, but RockSim won't change. I tried mass override to no avail. I'm sure it's user error. Thanks for any advice from sunny Newport Richey, Florida." Is Newport Richey on the East Coast? Which is probably why it's sunny. Or it's always sunny after the hurricane goes through. I hope you're doing well there, and I hope you didn't get rained out. Let's see. So, all right, so I saved that design. Let me go to Robert's question. What time is it? Oh, we still got time. I'm just looking for, let's go to an Apogee kit, open, Avian, open. Okay, so here's an Avian, and here is the 2D. So right now, our center of gravity is way here. What's going on with this one? Why is it so far forward? I probably got this M here is probably a mass of something. So let's go look at the design components. So what I'm looking for is I'm looking at the weights of things. And I got 4 grams, 8 grams, 1 gram, 2 grams, 2 grams, 50 grams right there. There's why. So let's delete that. Delete. Say yes. All right, so that's better. So right now, so Robert, when you look at a design, what I want you to look at right here is see if there's anything that says user specified in the text here. Because if it's user specified, that means there's an override has been turned on. So right now, I don't have that showing. So right now, I can manipulate that center of gravity any way I want. So if I go to the nose cone, and like you were doing, you can put a mass object in there. I'm going to click cancel here, and I'm just going to say it's a general mass, and let's call it like 8 grams. And you can see it put it right there. Let me go to 2D. It's right there, and it moved. Remember, our center of gravity used to be here, and now it's here. I think if you hit the hide button, it goes back. So basically, I'm hiding that mass, and if I unhide it, you can see my center of gravity is moving. So that's one way to manipulate it. But if yours is not moving, you got something turned on. Save my changes? No. Okay, so right now my CG is at 8.94 seconds. So what you want to do is you go to the mass override tab and make sure that this is unchecked. If it's checked, it's going to move your center of gravity. So right now I'm at 8.9 inches from the tip of the nose cone. I can see 8.9 inches right here. And that's measured from there to there. And so if I move my sustainer, if I make it 11 inches, and no, that's not that's not inches. This is the one, sustainer, 11 inches. So I want to move it back. So now I need to give the weight of the rocket some weight. So currently I'm weighing 23 grams. So let's say if I make it 23.458. So now the weight is going to stay the same as soon as I check it, but the CG is going to change, and it should change to 11. So if I check that box, the CG moved back here. As you can see, the CG moved here. The mass didn't change, but now look also over here, and now it says user specified. So now the user has specified that I want to move that center of gravity around. So that's how you would do it. You would move either the weights of the rocket around by adding mass objects, or you can move the center of gravity manipulating it by using a mass override. By default, this is turned off, but sometimes it's turned on. And the way you can tell it's turned on is by if it says user specified right here. David Hayes says, late again from Michigan. Well, better late than never, David. Alfred Indy says, I expected Terry to be launching into the hurricane. And Terry says, yeah, let's launch it in a hurricane. To combat weathercocking on multi-stage, you got to minimize the fin size so the rocket goes straight up. All right, so what I wanted to do, since we're going to come back to that, I want to open up RockSim Pro. And I want to open up that same design of the four-stage rocket in RockSim Pro, because RockSim Pro should be able to show us the launch visualizer, what it looks like. Okay, so if I recall, I saved it to my desktop. Estes Nike Cajun. Opened. Come on. Did I not select it? Open. Okay, so there's my four-stage rocket. Here's that last flight simulation. So here's the one that we want, A10 to A10 to A10 to A3. And what we're going to do, okay, so staging is different in RockSim Pro. So we're going to see that. We're going to load those engines again. I'm going to click Edit. Okay, so opening up the Edit allows us to edit our situation. So we got the upper stage, booster 2, booster 1, and then another booster 1, which is, I guess, booster 0. Okay, so we have A10 zeros in these three stages and an A3 6 in the upper stage, and I chose that because I wanted the really long delay. So flight events. So now what we have here is, I'm not seeing my my pod. Okay, so we have staging on the bottom stage. I'm going to say at a time of 0.85 seconds. I'm not sure this is going to work. Stage. What's 0.85 and 0.85? 1.7. 1.7. And then this one has a streamer at maximum ejection delay. So we have 2 staging events. There should be 4 staging events. 3 stage events. Or there should be a strap-on pod event. Starting state, launching straight up. Well, let's see where we're going to do this. So I'm launching. Choose a launch site. We'll choose Pueblo, Colorado, and do a flight profile. It might not work here in RockSim Pro because I can't control that pod. Okay, so I'm seeing the 4 stages. 1, 2, 3, 4. Let's turn off the, I want to leave that on, but I want to turn off the smoke. I want to have the flame, but no smoke. And I want to turn off the weathercocking cone and turn off the intervals and click OK. All right, so let's launch this rocket. Okay, so I'm trying to give you the lay of the land here. So right now, north, down here in the bottom left corner is a compass. And so north is pointed up. So a rocket is that red dot. It's pointed this way. It's going straight up. And this is 3-dimensional. So let's launch it. So there's 1, 2, 3, 4. This time, we must not have any wind because it's going straight up. I'm looking for the booster. So that booster, that's the pod. It stayed on the pad. Oh, there's 2 of them right next to each other. One is kind of angled downwards. This one's over here. This blue line here is one of the pods that landed near the pad. And the rocket, I think we need to add some wind so we can try to see what's going on. But it went 1,182 feet. Let's look at the plot of the graph. Again, we want to plot thrust. So I'm looking for thrust, total thrust, and we can go relative velocity. Absolute velocity is absolute relative to the center of the Earth. Relative velocity is relative to the point on the surface of the Earth. And let's clear out this one. We don't need to see this one, and plot the graph. Again, we need to see, are we getting 4 spikes, 4 independent spikes? I'm seeing 1, 2, 3. So I'm not getting a 4th spike, but the second one is massive. So we had 2 motors firing at the same time, but I don't know which 2. Let's enlarge this graph. So I need to see like the first 5 seconds. I'm going to go back to preferences. My graph ending point is at the following flight time of 5 seconds. And plot the graph. Okay, so here are the thrust curve. The first one, here's the second one, here's the third one. And you can see we're getting a big spike here. It's almost like, so this one is a little over 6 newtons. This one is almost 12. So if we double the spike, we should have got greater than 12, because this is greater than 6. So I think I have to figure this out. I think it's because if I were to put the pod, instead of putting the pod down here, if I put it above here, no, that wouldn't work. It's got to go below, because I don't think I can move it down there. I'm thinking out loud here. This is this is how we learn what RockSim can do in RockSim Pro. It's just by playing around. So RockSim can do it. RockSim Pro, I need to think about it some more. I have no idea if my feed is going out. Because I'm just getting a spinny ball on my monitor here. Anyhow, It's almost 3 o'clock, and I don't think I got any more questions. Terry Wheelock says, can RockSim simulate a sun sensor rocket? And the answer is no, because it's unguided. All of our rockets in RockSim are unguided, so we're not looking for a point in the sky. And we do that for a reason, because if we did allow it to be guided, then RockSim would basically fall. It's a classification from the Defense Department. It would be ITAR regulated, which means we couldn't sell it to normal people. Because it can't allow targeting, we can sell it to everybody. Who else would like a default launch field and condition settings in RockSim? Then it would always be our home field. Yeah, can you do that? I don't think you can save it in RockSim like you can in RockSim Pro. So let's go to launch. So what he's looking at is this launch conditions. In RockSim Pro, we can save conditions and we can save a field. But in RockSim, we cannot. Although what I think is once you set a different number, let's set this altitude to 4,500 feet, like we're here in Colorado somewhere, and say, okay, let's launch one time. I didn't put a motor in it. So let's put a motor in it. Choose an engine, D2410, click OK, launch. The rocket crashed. We must not have, what did we do wrong? Let's try that again. Engine mount D24 oh, I know why it crashed, because the 10-second delay is like way too long. Let's try a 5. Launch. Okay, now we got it. Do save. Let's quit. And now let's open RockSim back up and see if it remembered the settings of our launch field. Remember, we set it to 4,500 feet above sea level. This might be the closest you get to having it saved. So let's just open up a design, click open. Let's go to prepare for launch. I want to go to the launch conditions. Yeah, it remembered the last use of what I had. So as long as you save it and then close and then open it up and don't change these ever again, then it will always be your launch site. That's the only way you can do it in RockSim. But in RockSim Pro, you can save sites and you can save conditions. Anyway, I think we're really close to 3 o'clock, so we've gone an hour. Yeah, we got 3 minutes. But it wouldn't be justice if I went to another question. So we'll call it a day here. This will be like one of the first times we've ever been early. 2 minutes early, 3 minutes early. So thank you again for coming. We will be back next week. Next week is already October 4th. We will be back and same time, 2 p.m. Mountain Time or 4 p.m. on the East Coast. Yeah. So I'll give you a countdown and a launch. So in 5, 4, 3, 2, 1, go out and launch something.